Lab number 8, acid-base titration. Titration is a stoichiometry method that means a process to work out the exact concentration of the solution you want to use to determine the concentration of unknown solution. Our working example will be the reaction between sodium hydroxide and potassium hydrogen betallate, which will give us H2O and sodium potassium betallate. First of all, you have to balance the equation, your equation, so you can't work with the unbalanced equation. The molar ratio after balancing the equation is 1 to 1 to 1 to 1. This is the given information for our equation that the mass of potassium hydrogen betallate equal 20.4 gram per liter and the molecular weight is 204.22 gram per mole. Calculate the number of moles of NaOH. From our equation, the molar ratio is 1 to 1 to 1 to 1. So, the number of moles of NaOH equal the number of moles of the KHP, which equal mass over molecular weight. And it equals 0.001. To calculate the molarity of NaOH, it means number of moles over volume in liter. And the volume is unknown. We are going to calculate our volume when we make our practical part. For our practical part, we need the following: phenolphthalein indicator, NaOH, sodium hydroxide, and it will be our titrant. KHP, it will be our analyte. We will add 10 ml of KHP to our Erlenmeyer flask by using the pipette and pipette filler. This is our KHP. We will add 3 drops of phenolphthalein indicator, and as we said before, phenolphthalein indicator under acidic conditions will be colorless, Okay, we will fill our curate with the titrant in NaOH. Titration. The volume consumed of NaOH during titration is 11 ml. As we said before, to calculate the number of moles of NaOH, it equals the number of moles of KHP and it equals 0.001. For calculating the molarity of NaOH, we have our number of moles which equals 0.001 and the volume in liter equals 11 multiplied to the power minus 3, which equals 0.09 molar. Okay. To discuss this chemical equation, we have 2 points. KHP is our primary standard, and NaOH is our secondary standard. What does that mean? We considered the KHP as a primary standard because the mass of the KHP was known for us. So we use the information of KHP to calculate the number of moles and the molarity of our unknown, which is NaOH. So we call NaOH a secondary standard because it was unknown and becomes known in this standardization process. Part B of our practical experiment, that we are going to react the NaOH with the HCl. We put 10 ml of NaOH on the Erlenmeyer flask. We will add 3 drops of phenolphthalein indicator. Look, as we said before, phenolphthalein indicator under basic condition become pink to violet. Now we will start our titration in NaOH with HCl. The color must be diluted until it disappeared. We reach the end point and take 13 ml of HCl. It's consumed during the reaction. Our reaction is sodium hydroxide plus hydrochloric acid will give us sodium chloride plus water. As we said before, that sodium hydroxide is our secondary standard, so it is our reference to know the molarity or the concentration and the number of moles of HCl. So the first question is to calculate the number of moles of HCl, which equal the number of moles of NaOH, and it is equal 0.001. To calculate the molarity of the hydrochloric acid, which equals the number of moles over volume in liter, 0.001 divided by 0.013 equal 0.067 molar.